June 8, 1966. Somewhere over the Mojave Desert, at 40,000 feet, the most advanced bomber ever built was flying in tight formation with 4 chase aircraft. It had been brought together not for combat, not for a classified test, for a photo shoot. A General Electric publicity photo shoot, and in the span of 16 seconds, the most expensive, most ambitious, most dangerous aircraft program in American history ended in a fireball over California. But that wasn't what killed the Valkyrie. The Valkyrie had already been killed, years before. In a Washington budget meeting, by the very technology it had been built to outrun. This is the story of the XB-70 Valkyrie, America's Mach 3 bomber, a machine that cost nearly $1 billion, that nobody knew how to stop, that was obsolete before it ever flew, and that the Pentagon buried before the American public ever understood what they'd paid for. To understand the Valkyrie, you have to understand the fear, not abstract geopolitical fear, specific technical, classified fear. By the early 1950s, the B-52 Stratofortress was the backbone of American strategic deterrence. 8 engines, intercontinental range, nuclear payload. The cornerstone of Strategic Air Command's plan to flatten the Soviet Union if it came to that, and the Soviets were already building the missile systems to shoot it down. Soviet radar coverage was expanding across the northern approach routes. The routes American bombers would have to fly over the Arctic to reach their targets. Surface-to-air missile batteries were multiplying, and the B-52, for all its capabilities, flew at roughly Mach 0.9. Subsonic. A missile didn't need to be particularly fast to kill something moving at Mach 0.9, so the Air Force asked a simple and terrifying question: what if the bomber simply couldn't be caught? The formal requirement came down in 1957, a new strategic bomber to replace the B-52, capable of Mach 3 cruising speed, flying at 70,000 feet altitude, with intercontinental range and a 50,000-pound nuclear payload. No aircraft on Earth could do this. The Air Force wanted it operational within a decade. 6 contractors were invited to compete. 2 made the final cut. Boeing proposed a conventional supersonic design, capable and credible. North American Aviation proposed something else entirely, something that, by any reasonable engineering standard, should not have been possible. Their design was called the B-70, and it was unlike anything a military procurement office had ever seen. It was enormous, 196 feet long, a wingspan of 105 feet, 6 General Electric turbojet engines mounted side by side in a massive pod under the fuselage, each one producing 30,000 pounds of thrust. Together they generated enough sustained power to push a 490,000-pound aircraft to Mach 3, 3 times the speed of sound, at 70,000 feet. But the performance numbers weren't even the most audacious part of the design. At Mach 3, conventional wings don't work efficiently. The aerodynamics change completely. Air stops behaving like a fluid and starts behaving like a wall, generating shock waves that tear at the aircraft structure and bleed away energy. North Americans' engineers had figured out how to use those shock waves. The Valkyrie's outer wing sections could fold downward, up to 65 degrees during supersonic flight. This created a channel beneath the wings that trapped the shock waves generated by the aircraft's own bow wave, compressed air, riding under the belly, pushing the aircraft upward. The B-70 would ride its own sonic boom. Like surfing a wave, you generate yourself. No aircraft had ever done this. No aircraft before or since has done it the same way. On December 23, 1957, North American's proposal was declared the winner. On January 24, 1958, a contract was signed. The Valkyrie program was officially born. What followed was 5 years of engineering that pushed every boundary American aerospace had ever established. At Mach 3, aluminum, the standard material of aviation, simply melts. The skin temperature of the aircraft during sustained high-speed flight would reach 275 degrees Celsius. Aluminum fails at roughly 150. The entire airframe had to be rebuilt in stainless steel and titanium, not welded, brazed. A honeycomb structure of stainless steel panels bonded at high temperature, creating a skin that could absorb and dissipate thermal energy across thousands of square feet of surface area. The fuel system was redesigned to act as a heat exchanger, pumping fuel through channels in the airframe en route to the engines, absorbing the heat from supersonic friction and carrying it away before it could damage the structure. The pilot's windshields retracted into the fuselage for high-speed flight to eliminate drag, like a car's convertible top closing in reverse. The crew sat inside what was essentially a pressurized capsule inside a machine that was designed to operate in conditions that would kill them without it. The engineers worked with slide rules, wind tunnels, intuition built from flight test data that had never existed before. If something failed in the Valkyrie program, it failed at Mach 3, at 70,000 feet over the desert, with no precedent to guide the recovery, and things did fail. On May 7, 1965, a 3-foot section of the wing apex broke off in flight. On October 14, 1965, the first prototype exceeded Mach 3 for the first time. The heat and aerodynamic stress damaged the honeycomb panels so severely that 2 feet of the leading edge of the left wing came back missing. The first aircraft was immediately restricted to a maximum of Mach 2.5. Only the second prototype, AV-2, delivered in May of 1965 with improved wing geometry, could sustain full Mach 3 flight. A V-2 eventually flew above Mach 3 for 32 consecutive minutes. 32 minutes at Mach 3, at 70,000 feet, in an aircraft designed by engineers using slide rules in a decade when the most powerful computers in existence filled entire rooms. But the program had already been canceled 4 years earlier. In 1961, before a single Valkyrie had been built, before a single test flight had occurred, the Kennedy administration killed the B-70 bomber program, not quietly, publicly, over the Air Force's furious objections. The reasons were layered and brutal. The first was a Soviet missile called the S-75 Dvina. NATO called it the SA-2 guideline. You probably know it by what it did on May 1, 1960, when it knocked a CIA-2 reconnaissance aircraft out of the sky at 70,000 feet, the same altitude the Valkyrie was designed to cruise at. If a missile could kill a U-2 at 70,000 feet, a slow, lightweight, unarmed reconnaissance aircraft, it could kill a B-70 at 70,000 feet. The entire strategic premise of the program, that altitude and speed made a bomber invulnerable, had just been disproven over the Soviet Union. The second blow came from physics that no amount of engineering could solve. At Mach 3, a large aircraft cannot maneuver well. The aerodynamic loads at that speed make sharp turns physically destructive. The Valkyrie flew fast and straight. It was predictable. A Soviet radar station could plot its course and calculate where it would be in 40 seconds with devastating accuracy. A high-altitude Mach 3 bomber, it turned out, was actually easier to intercept than a subsonic one, because the intercept geometry was simpler, because the approach was predictable, because there was nowhere to hide at 70,000 feet. And then there was the third problem, the missiles. ICBMs, intercontinental ballistic missiles, don't need pilots, they don't need runways, they don't need fuel efficiency or crew rest or maintenance windows. They launch from silos, arc through space, and arrive on target in 30 minutes. They cannot be recalled once launched, but they can be ready 24 hours a day, 365 days a year, with essentially zero operating costs per launch compared to a fleet of the most complicated aircraft ever built. The math was simple. A fleet of B-70 bombers would cost billions to build, billions more to operate, and could be rendered strategically irrelevant by a missile system that cost a fraction of the price. Kennedy's Secretary of Defense, Robert McNamara, ran the numbers. The B-70 program died. But here's what Washington didn't fully anticipate. The Air Force had already spent 4 years and hundreds of millions of dollars building the most advanced aircraft program in history. 2 airframes were almost complete. You don't throw that away. In 1964, the first XB-70 prototype was completed. On September 21, 1964, it flew for the first time, and it was extraordinary, not as a bomber, not as a weapon, but as a research platform. The most capable flying laboratory ever constructed, a machine that could generate data about sustained Mach 3 flight, aerodynamic heating, structural behavior at extreme speeds, and sonic boom characteristics that no other aircraft could provide. NASA joined the program. Scientists redesigned the test schedule around research objectives. Instruments filled every available space in the airframe. The Valkyrie became, in the words of the officials running the program, the world's largest experimental aircraft. For 2 years, it flew. It gathered data, it pushed aerospace engineering forward in ways that would shape every supersonic aircraft designed in the following decades, including the Concorde, the SR-71, and every high-speed research program that followed. Then came June 8, 1966. The General Electric Company had a marketing idea: 5 aircraft that used GE engines, the XB-70, an F-4 Phantom, an F-5, a T-38 Talon, and an F-104 Starfighter, would fly in tight formation over the Mojave Desert for a publicity photograph. A 6th aircraft, a Learjet, would photograph the formation from outside. It was not a military mission, it was a photo shoot. Everything about it was unofficial. The formation flew, the photographs were taken, the aircraft began to separate, and then the F-104 Starfighter, piloted by veteran NASA test pilot Joe Walker, drifted a few feet too close to the Valkyrie's right wingtip. Contact. The F-104 flipped, rolled inverted directly over the top of the XB-70, struck the bomber's twin vertical stabilizers, exploded. The Valkyrie flew straight for 16 more seconds, then, without its vertical stabilizers, with its left wing damaged, it entered an uncontrollable spin and crashed north of Barstow, California. Co-pilot Major Carl Cross was killed in the crash. Joe Walker died in the F-104 explosion. The program's most capable aircraft was gone. The sole remaining Valkyrie, AV-1, the first prototype, already restricted to Mach 2.5, continued flying research missions for NASA until February 4, 1969. Then it made its final flight to the National Museum of the United States Air Force at Wright-Patterson Air Force Base in Ohio, where it still sits today. The funny part, B, if you can call it that, is what the Valkyrie actually achieved, not as a bomber. It was never a bomber. It was canceled before it ever carried a weapon. As a research platform, the data it generated was foundational. Every study of aerodynamic heating at Mach 3, every analysis of sonic boom propagation, every investigation of large aircraft stability at extreme speed, every engineering solution to sustain supersonic flight in an airframe that had to survive thermal stress, structural load, and fuel management simultaneously, it came from the Valkyrie program. The Concorde used it. The SR-71 program drew from it. NASA's supersonic transport studies built on it. Nearly $800 million in 1960s money went into building 2 aircraft. One was destroyed in a photo shoot. One sits in a museum in Ohio where a restoration team once had to deflate its landing gear tires to get it through the hangar doors because its twin tails were 2 inches too tall. The most capable aircraft America ever built, grounded, because the world it was built for changed before it ever got there. Today, the B-21 Raider, America's newest strategic bomber, flies at subsonic speeds. It is invisible to radar. It does not survive by being faster than everything. It survives by being undetectable by everything. The philosophy is the opposite of the Valkyries, not speed, stealth. 60 years after the XB-70 program was canceled, the Air Force has concluded that you cannot outrun modern air defense systems. You have to disappear instead. The engineers who built the Valkyrie would have found that deeply unsatisfying. They were trying to build something that couldn't be touched. They got close, but the world moved faster than they did. Subscribe if you want more stories about the machines that almost changed everything. The programs that cost billions flew once and quietly disappeared from history. New episodes every week, and drop it in the comments. Could the Valkyrie have survived if it came a decade earlier? Or did the missile age make it obsolete the moment the drawing board was cleared? We read every one. See you in the next one.